Good morning, good evening, good afternoon from wherever you're joining. We're glad to have you with us on this amazing session on the future of C#. And what we're going to be talking about this 1 hour is going to be about C# 9.0, which I think is probably the latest and greatest addition to the C# existing suite of libraries, the C# programming language, the .NET framework, and there's a lot more coming. And I won't be doing a lot of the speaking today, and I'll just very quickly introduce myself and then hand it over to the man, the myth, the legend, the gentleman you've all been waiting for. So my name is Lawrence Mudoga. I look after the developer ecosystem for Microsoft across the African continent, and this session is part of an amazing series of sessions we call Power Africa. And the concept of Power Africa is to take the latest and greatest, the best of the technologies that Microsoft builds and give that information and share that information with you. And that's what this session is all about. And when is our main Power Africa event? The 5th of November. Just like that old poem, remember, remember, the 5th of November, the gunpowder treason and plot. I see no reason why the gunpowder treason should ever be forgot. I'm impressed I can remember most of that. So let's do some quick housekeeping before I hand it over. Please do ask your questions whenever you have them. I'll raise them with our amazing speaker as they go on. So if you have any questions, any comments, anything you'd like to share, please leave it in chat. We'll actually pick it up and share that. And most of all, we look forward to actually hearing from you, listening to your ideas. What would you love to see in the platform? And why would we do that? Because the gentleman we have as our guest today is none other than the lead designer of C# himself. It's Mr. Mads Torgersen. And over to you, Mads. Thank you for attending this. And to your audience, we'd love for you to enjoy this session. So keep the questions coming. We're glad to have you. Over to you, Mads.
Well, thanks so much for the warm welcome, Lawrence. It's really great to be here. I am honored to have such a broad audience in across Africa, and there might be a few peeking in from elsewhere. Welcome to you too. So yeah, I'm really excited to have a conversation with you. I did bring some slides and some code. I'm going to show you some things, but I'm also eager to hear your thoughts, and both in terms of questions to the stuff I present and things that you wish for, or things that you find that are hard in C# and want to raise with us, whether we can do something about. I really want this to be the start of a conversation. So with that, I'll probably start out talking a little bit about just how we think about language design on the C# design team, and what our sort of language strategy is. Because we have one of those, and eventually when you do something long enough at Microsoft, you have to have a written down strategy for it, or they close you down, right? So so we do have that, and it's not all made up. It's actually fairly well thought out. So the C# language strategy, if you want to read the whole thing, there's a link there that you can go and check it out. But and it's sitting there together with the VB and the F# language strategies. But there's sort of some main points that I just want to draw out here today. And the first one, I won't say the most important. They're all equally important. The first one is that we really want to lean into evolving the language and innovating in the language. So you kind of, when you have a programming language, you kind of have a choice between being fairly conservative and being trying to keep the language changing as little as possible, or you can lean in more and say, hey, we want the language to evolve with the times, and we're sort of very committed to doing the latter. We think that C# should be a programming language that you want to pick up for your next project, That you don't just want to work in C# because that's where your code already is, so that's where your legacy projects live. It should be a good choice for your next project as well, regardless of whether you have assets already. And that means there's a fair amount of evolution in what you build when you develop, how you do it, what kinds of things are important. And we need the language to keep up with that, to keep up with general innovation in the language space, and offer good strategies here. Not just copy what others think of, but also ourselves from time to time be the ones that innovate and put new language features out there in the language community. That has happened a couple of times where, for instance, you see async await being picked up across the board now in JavaScript and elsewhere. And that started out in C#, for instance, with us pushing that approach to asynchrony into C#. So this is something we're very committed to. It does have downsides. It means that the language keeps growing. And the thing about a programming language is that you can't really take anything out. It's really hard to take something out because people have code written in it, and that all that code won't compile anymore if you take out a feature that you're using. So so we really have to, one way we sometimes put it is we only want to put in features that we would want to wake up next to 20 years from now. Like every language feature we're sort of getting married to. It's there forever. And so we want to think really hard about what we put in and not try to just follow the latest fads, and be as economical as we can with the surface area of the language, because it can only grow. But at the same time, we don't want to let that scare us away from doing the good and necessary things. So it's kind of this balancing act of innovation. And we're on the sort of, compared to some languages, we're on the fairly aggressive side when it comes to evolving the language. As we do so, we have to recognize that C# is being used for a surprising array of different scenarios. So it kind of started out as a language mostly for apps on Windows back 20 years ago. It could only run on Windows back then, and there was only so much you could do. There was no cloud. But C# has been, and we have supported this all along, has moved to a really broad number of different types of development and types of scenario that it's being used in. And so we have to be cognizant of that as we evolve C#. We have to keep it general purpose and make sure that the features we put in are to the benefit of all these different C# developers, or at least the vast majority. Sometimes we put in features that not so many people will use. In recent releases, we put in a number of features that are kind of low level, that deal with having refs and structs and things, so you can avoid allocations and write more efficient kind of low level code. And we don't expect as many people to use those features directly, but they will still benefit from them, because these are features that will make the lower layers that you build on top of, the libraries, the frameworks, that will make them more efficient and use abstractions that are more that benefit you indirectly. So that counts too. We've made quite a lot of headway in these things. And some of you, if you see some of the benchmarks out there, for instance, like the Tech Empower benchmark that shows different stacks in web scenarios and compares them. We're doing really well there and have kind of risen solidly into the top 10, comparing to other languages through many, work on many different layers, but one of them being these language improvements. They're sort of central to a lot of that improvement. The third thing I want to highlight here is the community aspect of it. C# started out like all Microsoft technologies 20 years ago, being built in secretive, back rooms. You imagine, these shady deals hidden from the. It wasn't quite shady, but innovation just happened in the way we did innovation was to in closely guarded environments. We treated it all as trade secrets, and only when we were ready would we come out at some conference. Anders Heilsberg would go on stage and say, "Ta-da! Here's the next version of C#, and it has all this new stuff." And it would be almost ready to ship by the time we would show it. And that was then, but we gradually realized with C# and the .NET platform in general, and now many of the Microsoft technologies, that we were missing out on a whole lot here. We were kind of lucky that we mostly did good things to C#, but we actually lacked a feedback loop. I think it was only through the amazing intuition of Anders Heilsberg, who was the lead designer back then, that we were so lucky with hitting mostly right notes in that time frame, because we really lacked a community feedback loop. And so we've gone through a tremendous evolution here, and C# not only the compiler but also the language design itself is an open source process. Everything we do in the open, and so we can get very fine-grained and very broad feedback on everything we do in real time, and that saves us from a lot of mistakes, big and small, from shipping the wrong features to also just making sure that the little details are right. Because once they're there and once people depend on them, you can't change them. So it's really important to have this feedback loop before you ship. At the same time, you don't want to get into a situation where a language ends up sort of like designed by committee, kitchen sink. One of the things that people express that they enjoy about C# is that it is a fairly cohesive language. Like, we go to great lengths to make the new features fit in with the old, and expand on a cohesive whole rather than bolt things on that don't quite fit. And so for that, it is important to have a fairly strong stewardship. And so we have a language design team that makes the decisions and kind of filters and integrates the community suggestions and feedback, and takes responsibility for sort of the holistic view and the long-term view of what C# should be, so that we don't get this kind of bolt-on feeling to the language. So that's how we think about evolving C#. And I'm wondering at this point if there are people who, before we dive into the technical stuff, if there are people who have thoughts or questions about this.
We actually do. And I think one of the questions that has really popped up, and I think this is actually very true due to the number of mobile applications that are built within Africa, is they'd love to know what's happening around cross-platform development with C# and Xamarin, and any information that you may have around that. And that's actually quite a number of the questions that have come in. So I'll hand that over to you.
That's great, because as you know, so you mentioned Xamarin, which is, I can now say, our mobile platform, but it wasn't always our mobile platform where, as you know, Microsoft is concerned. Xamarin is sort of like was sort of like the latest project out of the Mono effort, which was an effort outside of Microsoft by people who loved C# and .NET to make it cross-platform back when, as I mentioned, we were all about Windows in Microsoft. So other people saw the potential of C# and .NET to be a great cross-platform developer stack way before Microsoft did. And it's only been in later years that we then realized, okay, or the last almost a decade now, that we realized, okay, we really need to get away from this, and C# should be cross-platform. And so one of the things we did was we collaborated with Xamarin for a long time, and eventually we acquired them, and have been working ever since to take what were very different tool stacks and products and integrating them further and further. And we're actually quite ambitious, and some of you will have heard announcements at Build and so on about the degree to which the cross-platform story, that Xamarin started, that Xamarin Forms in particular started to become a broader cross-platform story for .NET UI building. And so we've announced the Maui project, which currently we're looking at. That the current plan is to ship it with .NET 6 late next year, but we'll see how things go. But that's where we're aiming for right now, where that further integrates the stack that started as Xamarin and broadens it not from being less focused on just mobile to reaching more across to also the desktop form factors. So I'm very excited that we're sort of getting into having a proper cross-platform UI framework. There are many details still to be worked out here, but this is a very exciting development, and I think so. This thing is something we're leaning into. Xamarin has felt a little, it came in as a completely separate product, and it's taken a while to sort of just fully integrate the sense. It felt like, okay, I'm going over here and I'm doing something Xamarin versus working on, the desktop form factor or working with different UI frameworks. And that is something where you should, just like everything else in .NET is being unified and becoming one platform with shared abstractions and shared frameworks across, so should the UI experience. So that is at the high level. That's the main thing that's happening there.
Nice, thank you. That's super comprehensive. And I think I'll ask one more questions, and we can save the others for our next part. And you've mentioned community in the slide, and I think this one comes from our gaming community. Do you have any news on Unity 3D supporting .NET 5? It's more of a .NET question, but I'm pretty sure they're super interested to see whether they can use the new features.
Right. So I don't have news there. We should probably let Unity bring the news. Unity, for those who are not aware, is a gaming platform that uses, again, a version of .NET that they support that's optimized for writing games, ranging all the way from casual games up to very high-end, top-of-the-line games written, using CSharp, which I am baffled and humbled by. And we have a great collaboration with Unity, because since they have their own version of .NET and of CSharp, well, it's the same language, but they have their own stack implementing it that's optimized for gaming. Obviously, there's this challenge of bringing the latest features into Unity once they come out in our own stack. And we've really increased our collaboration with Unity here and shortened the time it takes and lessened the burden they have when they're adopting new things. So I can't tell you what the timeline is, but I know that we're working closely with them, and these things tend to go faster and faster. So they've been very good lately at bringing in the newest features. But as for timelines, we should probably ask them.
Okay, cool. Thank you. And over back to your presentation.
Okay. So actually, given that we talked about this a little bit, this might be a good time to let me just bring up a web page here. This is the C# Lang repo on GitHub. So C# is implemented by the Roslyn compiler, which has its own repo under GitHub, github.com/.net.roslyn. But the language design itself has a GitHub repo, which is where we do this open source design. So for instance, if you want to see what the C# language design team discussed in its recent meetings or back in the past, you can go in here and see that on in 2020, we had a lot of meetings. Here's the schedule in the README here, and we just yesterday we looked at required properties and we triaged some features for C# 10. This is what we did earlier, and then down here you can find little summaries of what happened. So on August 24, we talked a lot about records, it seems, and then you can click on the full notes and you can go. And so if you're really interested in drilling deep down and following, week by week, the C# language design, you can do so here. That's totally available for everyone to look at. Now, if we go up to the top and look at the issues, this is where we will have many discussions. There's issues and there's discussions as well. And when things are proposed, they become issues. If language designers like or think one of the features is interesting, they'll put this label on, and we'll discuss it in C# language design meetings. So support read-only modifier for classes and records is a proposal that just came up 5 days ago by a community member. And one of the language designers, it looks like that was Fred, who's on the compiler team. He decided to champion it. And that means that in a language design meeting in the near future, we'll be discussing that, and there'll be notes out on how we feel about it, whether that should be part of C# 10 maybe, or a later version of the language. So feel free to go here anytime, put your own suggestions or questions in. Typically start them out in discussions, and then once there's a formalized proposal with more of a specification, and it's been discussed in here with the pros and cons, it can you can log it as an issue, and we can discuss whether to do it and polish the design. So this is really just a completely open process. But going back to the presentation, well, actually, the next thing I'm going to do is to talk about C# 9. So that was a short little bit of presentation here. Let's look at some Visual Studio. I have let's start here. So there are various themes in C# 9, but one of the things that's happening is, I keep talking and not going into technical details. I'm sorry, I have 2 hours. I can't help myself. But one of the things that's happening is that .NET is going into a yearly cadence of major releases every November. .NET 5 is coming up in November, and then .NET 6 after that, which is a long-term supported release. And the C# language releases, we think we're probably going to follow a similar cadence. So we just shipped C# 8 last year. C# 9 will come out with .NET 5 in November, and then we'll probably have major releases after that. So C# 9 here that we're looking at a couple of months out. And of course, you can download previews like the one I have here of Visual Studio or the SDK, and you can play with it yourself. So this is all things you can try at home. Though I do think that it's an internal preview that I have here. It might be a little ahead of you, but not much. So here's the main program. One of my usual person examples here that's easy to fit on a screen. One of the things that's actually super annoying and feels like so last century is that you have to kind of dig in through all these layers in order to find your main program, in order to get to the source code that is actually the main thing that happens in a console app, for instance. This is the main program, but there's all this goop around it and this 2-level indentation. And so we figured, hey, why don't we just get rid of that? Why don't we let you not say, put your main program in a main method, but just let you put it at the top level of a file, And that is now in C#, C#9 totally allowed, having top-level main programs. So this is just statements, a local function declaration, and statements, and it totally works. So there you go. And I think that we're going to see a few more features like that that are just going to make, say that you're coming to C# for the first time and you're trying to learn it. There are all these, you want to reduce the number of things that you tell people, well, you just have to put this thing and you have to put that thing. And then you can just ignore all that. You just have to write it. And then in here, you can start writing your first program. That's all, adds to confusion, makes it harder to learn the language. But so we decided that, this needs to be simplified. But simplification, I think, is not just for when you're learning the language. It's just when there's less code, it's easier to read what you have. And in general, simplification is good. So we're thinking to do more things in that theme in the future. For instance, we're probably going to make it so that that's one of the things that we're discussing for C#10 is making it so that you can take your usings out you can take them out of the source file and maybe into the project where your references are, so that somebody who starts out from a template has maybe the standard system things just available, and your first program really can be just write line hello world, something like that. So this theme of simplification is one that runs through version after version of C#. I can't remove the usings yet, though. That's for a future version. But we could put the statements at the top level. Now, another thing that you notice here is, okay, I have a class and I'm using an object initializer to instantiate it. We've had object initializers for a long time now in C#. And they're really, object initializers are really a good alternative to constructors. And a lot of people actually mandate using them because constructors have various downsides. I mean, they're a solid feature, but they have several downsides. They're fairly brittle. So if you change your constructor, a lot of code gets broken by that. And if you build hierarchies of classes, you have this linkage between, we may see examples of this later, linkage between the base classes and the derived classes, where the derived classes have to have a constructor that takes in all the parameters to construct the base class. It has all this code just to take in these parameters and then pass them on to the base class without doing anything with them. Like, why do you have to repeat yourself so much? And object initializers are really much simpler here. You don't have to write a constructor at all. And so in particular, the constructor doesn't have to repeat itself. If I was making a derived class here, I could just inherit first name and last name and add my own thing, student ID or whatever. And then I would just be able to use object initializers on that too. So it's a really good feature. However, another thing that we're seeing more and more of is the use of immutable data. So immutable objects have become mainstream. It's sort of like a style of programming like so many good things came out of functional programming. But more and more, as we're working with data that is not stored locally here, more and more it's useful to represent data with immutable data types. Like the whole C# compiler itself, the Roslyn compiler that I mentioned before, is written with immutable data types, a syntax tree or something that represents things in the language. These are immutable types. And it's easy enough to make an immutable type. I can just remove the setter for the properties here, and now I have an immutable type. But now my object initializers don't work anymore because I can't write to these properties. So immutability and object initializers are on a collision course in C#. And we wanted to fix that. And so what we did to fix that was that we introduced a new accessor to properties called init. So you can see when I put init here, I can assign to first name. Again, the squiggle disappears. And what the init is it's like a setter, but it can only be used during object initialization. So once the object has been created, if I say person dot last name equals another Scott that we have, if let's say Scott Henselman tries to take over this object, he can't, because I can assign to the last name as part of the object initializer, but after that it becomes immutable. So now immutability is something that you can write immutable classes that work well with object initializers, and this kind of dichotomy is no longer there, where you have to choose. Or you have to, just because you like object initializers so much, you have to leave your objects. You have to, try to tell people not to mutate them after, because they're supposed to be immutable, but you leave them vulnerable to bugs where they do get mutated anyway. So no more of that. And I wonder if there are any questions on the stuff we've seen so far. Looks like Lawrence is, at least on my side here, is not succeeding in coming into the stream.
I was muted. Can you hear me now?
Let's see. I can see some of the comments myself here.
Okay, perfect. So we've had one question that asks around.
That's probably okay.
Ooh. So it looks like we're experiencing a small technical hitch, but Mads should be joining us shortly. Let's give him a few seconds. I love the discussions you are keeping going on YouTube, on the chat. I love it. I see a lot of conversation around the new features that you're actually trying out. Some of you are super impressed. Some of you are wondering, how do I use this? Or some of you are like, hey, this looks familiar. This looks a bit like Python. And who knows where this is heading? I don't know. So I'm also here to learn with you. And so what are some of the things you've noticed? What are some of the things you think are super interesting? What do you believe you might actually use? I've seen a lot of people are talking about the future of .NET, tools like Blazor and some of the some of the things that you can actually use within your presentation. I see some of you are saying the presentation gods have arrived. Maybe we didn't sacrifice a goat to them this morning. I don't know what they were asking for. I'm a firm believer in Murphy's Law. Things happen every once in a while that you do not expect. So we are collecting your comments and questions from the chat, so please do keep them coming. I think we'll try and answer as many of them as we can. So yeah, so what do you think? What do you think of the new features? Do you see yourself using them? Do you see yourself trying out a lot of these new things? Or do you see yourself, for example, for the mobile developers who've just heard about the changes coming to Xamarin? What do you think? Some of you are saying the init feature, the init function is pretty cool. I think it's pretty cool. The fact that you can initialize and enforce a bit of immutability, or mutability if you wish, I think is super, super cool. And of course, if you're maybe someone who's not used to C#, I think, and some of you have commented this, is it does lower the bar of entry, right? If you're used to Python, if you're used to PHP, if you're used to JavaScript, I don't think anybody enjoys writing public static void main args square brackets. etc., etc. Although Visual Studio does fill in those for you. Okay, so please do keep your questions coming in chat. Mads should be joining us shortly, and yeah, we'd like to actually discuss this. I saw an interesting question, and I'll try and answer it. Is open source the future? I'd say open source is a critical part of the future. The fact that communities come together and collaborate and build something not only challenges massive organizations like ourselves, but it also creates a space where people can collaborate and try new ideas. And so I would say open source is definitely part of the future. Is it the future? Time will tell. I think it's going to be a mix of everything, because on one side, you do have community developers who want to contribute and change things and build new things and make sure that everything is happening, or try new spaces that nobody has tried before. But on the flip side, you also have organizations that are building unique and complex programs. So open source will definitely be part of the future. And ladies and gentlemen, we have our host back. I'll welcome you back, Mads. Sorry about the technical issue, but we should have you back in a second. Yeah.
Yeah, I think it's all on my side. I lost the internet, the wired internet and everything, which this is Seattle. How does that happen? But so I'm now actually tethered to my cell phone hotspot, and we'll see how that goes.
Okay,
uh,
cool. All the best.
yeah, so I'm wondering where I lost you guys, um, but hopefully you were with me from most of this. Um, and and I was just showing how when I have an init only property, then it's like having a setter. You can declare actually with a body and everything. You can declare the initter just like a setter. I'm just using auto properties here, but you can do it with your own manually written properties. And if you declare it as an initter instead of a setter, you can't have both. But if you do init instead of set, then that limits it to being invoked during the object initializer. So this really unifies the object initializer style, this sort of name-based style of initialization, and the constructor-free class authoring. It unites that with an immutability discipline.
For a quick second, your volume is a bit low. So
okay, we
yeah.
will see if we can turn that up in StreamYard. Hello.
Not yet there.
Not yet. And it doesn't let me tinker with it. Let's see. Where else can I?
Could be your microphone, I believe.
Yeah. I could switch microphones. Let's try to do that. We're having fun with the technical issues here, aren't we?
It's Murphy's Law. Our community mentioned that we didn't sacrifice to the demo gods, and now we are being punished.
Is this better?
Much better. Yes, we have you back.
That is that's my built-in microphone on my laptop. So we're working our way through our fallback positions here. Let's see if we last through the whole thing. Okay, so let's see. Okay, so now that we've looked at init-only properties, so this is where I wondered if there were any questions, and I realized that I had been that you guys had not been hearing me for a bit. So any questions or comments on this?
Yes, we do. Oh, sorry. Yes, we do have a few questions. One of them is around namespacing, and how will you approach namespaces, either as a design plan in the future, or how will you do them currently on C# 9.0?
So namespaces as a language feature, I'm assuming that's what we're talking about. There's I mean, today, if you want to be in the namespace, so that's actually a good question that relates to what we talked about before with the, let's go here, with the top level statement. So if you want to write a namespace today and put things in a namespace, you have to write names. Where did I can't spell namespace. Name space, right? Namespace foo, open curly, and then we can put that whole vast class library here in the namespace. This is how you have to do it. And so if you have you get this sort of extra level of indentation for your whole file, essentially, when you want to write something in a namespace. At least you can say foo.bar.baz. You don't have to nest the namespaces one by one, but still, this is something that is yet again one of those annoying things where you pay a price throughout your whole source file just for being in a namespace. That price of indentation here, which every horizontal space counts. And so we are discussing whether you should be able at the top of a file or something to declare your namespace like this, and then that automatically counts for the rest of the file, right? So now let's see if I get to indent it. It almost works, but of course this is not a feature yet, so the compiler is a little confused. But essentially, write namespace here, and then the rest of the file is automatically within that namespace. Again, try to avoid that clunky nesting that is so last century. That's like looking at C programs, and so that's another that's great that you brought it up. That's another one of those places where we are thinking about making improvements. If we can, another thing that's clunky like this is try catch finally, which has a lot of curlies. Error handling in general is syntactically, or exception handling is syntactically fairly heavyweight in C#, and so it's one of those things that we might, if we can work it out, we might see if there are less indentation heavy approaches we can take. Essentially, it's just syntactic sugar, but it works to compress your code. And already, in C# 8, no, what's it about your C# 7? We introduced the or was it C#8? It was C# 8. We introduced switch expressions. I can't keep track of my C# anymore. Switch expressions, which are a lightweight alternative to switch statements. And so we're generally doing sort of a nip and tuck, making C# code leaner and cleaner, and sort of just, we continue to go around every release and see, are there some things that we can tighten up here where we can make your code just as readable, or maybe more readable, but using less characters and taking up less indentation space. So that namespaces are a good example of that. Yeah, thanks for bringing that up. Yeah, other things there?
Yes, there's one interesting question that's actually been brought up a couple of times, is will C#, and I think there's more general, not tied to these features, but will C# ever support compiling to assembly like C or Golang?
Oh, yeah, that's something that we've had a lot of efforts around this, and we continue to. So compiling to native, as we call it, is, as opposed to compiling to IL, and then just-in-time compiling the IL as you run it. In certain environments, it's preferable to compile all the way down and not, waste time and battery and so on doing the compilation as you're running the program. And we do have shipping technology for this, and on some platforms, like on iOS, for instance, when you use Xamarin to target Apple iOS, you do get ahead of time compilation, as we call it, and that is something that we are doubling down on, making available on more platforms. So whether it's a good idea for you or not, it kind of depends on the platform and the specifics around your app. but we want to make that a viable option that you can choose to go all the way down to assembly. Yeah, great question. Thank you. Anything else there?
I'll keep bringing them in, but I think we can continue.
Cool. All right. Yeah, so thanks for those questions. So we talked about immutability, and I'm going to keep on that theme for a little bit here. So one of the things that you do a lot nowadays is you just represent data, and representing data with classes is like this is fine, but it doesn't really treat it like data. It treats it like objects with identity. And what you want, especially when you're working with immutable data like this, is you want to treat it more like data. You want to have more of a value view of the objects and of the values here. When you so for instance, when you have a one of the things that you do often when you work in an immutable style is that you can't mutate the existing object. So if you want to express that something changed, you create a new version of the old object, and then use the new version to represent the. So now you have a representation of the state both before and after that change, rather than having destroyed the old one, so to speak. So we wanted to make it so that you could support. We wanted to support in the language a more value-oriented approach to data. So we have a version of classes now called records. Instead of saying class, you can say record. And if I say that this class is a record, I get some extra functionality. It changes a few things. So one of the things I can now do is that I can create. I still can't change Hunter to Hanselman, but I can create the version of this object that has the last name Hanselman instead of Hunter. And that's supported with a language feature that we call with expressions. And you'll find out shortly why, because we can say var other person for this new object equals the original person with, and then an object initializer that you can put as many initializers as you want into. And what this means is that we're creating a new person object that's exactly like the old one. It has the same type at runtime. It copies over all the state from the old one, except that it replaces the last name with Hanselman because we specified that in the with expression. And so this is how you can incrementally change to other things. So if we display the other person, display person of other person, and actually let's be brave and run this program. So you can see there's a Scott Hunter and a Scott Hanselman object at the same time. And that is how things like, for instance, Roslyn works. And so you can kind of see now how you can work with immutable data where there's a representation of both the before and after state, and you apply these transformations to get to the after state, but the before state is also there, which lets you do fancy things like diffing. So when you see a diff in a refactoring, for instance, here in Visual Studio, that's actually Roslyn's syntax before and after trees that get diffed for that view. But what's more is that when you do this thing, when you keep getting new objects representing the same thing at different points in time, then you also want a different notion of equality, which is value equality. So we could create yet another object. Let's call it the original person. That's the other person, but with the name changed back again. Last name equals Hunter. And for normal objects, they have reference equality. So if we print out, let's say the result of reference equals person dot reference. Oh, sorry, that's a static method. Reference equals of person comma original person. Then that does a reference comparison, and that should give us false, right? The original person is another object than the person we first had, which confusingly is the original person, I guess. Now, but if we write out the equals, calling the equals method, then that has been overridden. That's virtual, right? And anyone can override it, and the compiler automatically overwrites the equals method on these guys here to, let's see, man, I really have fat fingers here. Oh, they're actually not equals. Let's see. Oh, that's because there's a space in Hunter. It would be embarrassing if my new language feature that I was showing you didn't actually work. Let's try again. And now, they're equal. So that only goes to underscore the point. I did this on purpose to show the point that it will do a value comparison by comparing the contents. So two things are equal if the field inside, if the state inside is equal. It goes through, just like with structs already today, they also have value equality, right? And by comparing each field in turn. And this works exactly the same way. Like, we deliberately made it work exactly the same way that structs work, except it also works across inheritance hierarchies, which structs don't have. Both the width and the value equality, they work across inheritance hierarchies. They don't lose information about what the actual type of things are at runtime. So so that's value semantics for you. And that's the main thing that records are for. They introduce this value semantics here. And again, Lawrence, just break in if people start having questions about this.
We actually do have a few questions. Yes, so one person actually asked, are record types still a class, or is it a struct, or is it its own thing? Yeah.
Right. So we gave it its own keyword. You don't have to say class, and you can't actually say class, but it is a class. So it's a class with extra features. We decided that we wouldn't force you to say record class, because then that gets longer. And one of the things that you kind of want to do with a record typically is to describe data as tersely as possible. So we said, okay, you can just use the record keyword, but it is a class. But records are limited in certain ways also compared to other classes. And we'll talk a little bit about how some of those limitations will be lifted again in CSharp 10. So right now, you couldn't, records are somewhat special to the compiler. You couldn't write your own thing as a class that's exactly like a record. Or we couldn't have like a refactoring that turns your record declaration into a class declaration that's exactly the same. For instance, the way the with expression works uses things that you couldn't write yourself, okay? That we generate into the record that you couldn't write as source code. That is something that we think that's a temporary thing. We would like to get to where records are just a shorthand for writing your own class. And we want to put in features that would let you write your own with support, for instance. But we're not quite there yet. Another thing that we don't support yet is record struct, but that is also something that we would like to support in C# 10. So structs, as I said, already have value equality, but it'd be nice to be able to use withers, for instance, to use the with expressions on structs as well. So
okay,
that's something we'll get back to. Yeah, great question.
Great. The next question around that is, if you change some value of the property of the first one, does the second one change as well? And I think you might have answered this while you're talking about the value equivalency.
Yeah, so it's a good question. Now, I make them immutable so they can't change. And in general, you should, when you use value semantics, when you use records, you should typically have immutable properties, because value equality on objects is a little dangerous if the objects are mutable. That's because the equals in hash code will change over time for that object. And so if you put it in a dictionary, in a hash table, and you go look for it later, but it's changed in the meantime, then you can't find it again. It's changed its equality, right? So so there are good reasons not, and we have design guidelines to not generally combine mutability and value equality. But if you do it anyway, then it's a shallow copy. The other person that's created with a with expression is a shallow copy of the original person, which means that we do a normal assignment of each field. If it's a struct, then if that field is a struct, it gets copied. If it's a reference, the new object has a reference to the same. But since it's still a copy, the answer to your question is that if let's say that I made the first name settable, and StreamYard is hijacking my screen here. And if I make that first name settable, and we actually we set it here, so we can say person dot first name equals whatever Bill. Then we already created the other people here, and so if we run it, we should see that only the original object changed its first name. The object that was created was a copy, and it retained the old name because that was copied at that time.
Yes. Okay. Perfect. I think there's one last question from our earlier discussion, and this is: if there's no main method, how does the compiler figure out where the entry point is?
Because you're only allowed to put top-level statements in one file, and that's the entry point. So if you do this in two files in the same compilation, in the same project, then the compiler will just give you an error saying you can't have top-level statements in two files. So nice. If you do have top-level statements, that's the entry point. Otherwise, it'll fall back to the other thing and look for main and so on. And actually, we try to make it so that this is as expressive almost as having an explicit main method. So you don't quickly find yourself having to go back to an old-fashioned main method. For instance, there's a magic keyword in here called args. Even though there's no args parameter in scope, you could say args 0 here, and args is magically bound to be the command line arguments for the program. So you can generally live without. The only thing is if you want to do something like put attributes, special attributes on the main method or something like that. We don't support that. So if some of that becomes important, we will find a way to support it. But right now, they're sort of like 98% as expressive as the main method. And that's based on very scientific math.
Okay, and last question before we go back is, can we use set, get, and init all together?
No, you have to have. You can only have one of init and set. Think of init as a version of set that times out when the object it closes the door when the object is initialized. So when you reach this end curly here, then it's good night for the initter. You can't use it anymore. But other than that, it is the setter. We implement it as the setter. So it can't also be a setter. Then you could probably dream up scenarios where that would be useful, but we decided this was simpler. That it's simply a version of the setter. In fact, we considered whether it should just be a modifier on the setter that you put init in front. But again, we were opting for brevity here. So we said, okay, let's replace the set keyword instead of augment it. Okay, and
Perfect.
speaking of brevity, and another thing that we're also looking at that we haven't done yet is that it's going to be very common that you have records that have init-only auto properties and that are public. And so we actually wanted to create, and it didn't quite make it into C# 9, but we're queuing up the work as some of the first thing to go in preview in C# 10, is that we wanted to make a shorthand for this thing. We want to have something that we call data properties. And what a data property looks like is simply data, and then other than that, it just looks like a field. So it really is a public property, a public init only property, but the data keyword is sort of just an abbreviation for all of that. And the idea is that you get a record declarations or ordinary class declarations, doesn't have to be record declarations, that are very brief. And they can be one-liners. If you don't have any special methods or anything in there, they can be one-liner declarations. But try to have those data models be as succinct as possible is what we want to aim for. But we didn't quite make it there yet.
Okay.
One thing that we did get to though was I'm continuing on. Is that good? Or
Yes, that's very okay. I know there's one question that's to me though. Someone was asking me, is it load shedding? Yes, as you can see, the demo gods have punished me by taking away my electricity, but we shall persevere.
Yes. Wow.
Yeah, this is a proper blackout, man. So but we can go on. I'm still connected. Yes.
I feel like I'm bringing some bad vibes to all the tech here, but
no, we have C# 9, and it's awesome. So I'd say it's a small price to pay. Boom, there we go. That's a nice tagline for our marketing.
So one thing we've been talking about in general, but we're only doing it for records for now, and this is sort of like a special version of it, is what we call primary constructors. So if you want a constructor in your record, of course you can write one. It's just like another class. So we could have a public person, blah, blah, blah here. But we can also abbreviate that quite a bit by putting it on the public. Sorry, I don't want to put public here. I want to say a string first name, comma string last name. So I'm putting the constructor parameters directly on the class header itself. And what that does in a record is, in fact, it actually declares, unless you do something, it actually declares properties, public init only properties. You can also declare the properties manually. I'm doing that down here, and then you can declare them whichever way you like. You can even make them fields if you want. But if you leave them out, then properties are declared for you that are init only and public. And so you can see the they still exist as properties up here. Now, I can't use the object initializer anymore because I don't have an empty constructor anymore. So that is for if you want to construct with a constructor instead of an object initializer. That's totally allowed. And now you get a very terse and nice looking record here. In fact, I don't have to have the curlies. I can just put a semicolon, and that's a data type with a constructor and public properties and everything. Init only public properties. If you have what we call a primary constructor like this, you can add other constructors as well, and as long as they call the primary constructor. So I could have my own constructor in here that's public person, no arguments, and it says this null, comma null, for instance. I think that works. I'm gonna try this at home. Yeah, there we go. And now that's an empty constructor as well. Initializes the first name and last name with null. I don't have nullability turned on, so I get away with this today. Now I'm back to having a no arg constructed, and I can use the object initializers again. But you typically won't do this, but just to show you that you can have other constructors when you have a primary constructor. They just have to call through that one to make sure that these things always get initialized through the primary constructor. So that's what I wanted to show with records and everything. We do have some other features in C# 9 that I can also go and showcase. Just want to make sure we got every last question on this topic here.
We have two. Actually, I'll just wrap it into one question. Can records have methods, and can records implement interfaces?
Yes and yes. In that sense, records are just classes. They can have methods, they can implement interfaces, they can generally do everything that classes do. The only thing, and then they have all that special machinery. So it's more that classes can't do what records do. Because the records have some special machinery. There's one exception, which is that currently you can't inherit between classes and records. Records have to inherit from other records or from object, and then they can implement interfaces on the side. So you can't mix inheritance hierarchies between records and non-records. That's probably also a temporary measure. Once we get to where records could have been expressed as ordinary classes, then it also makes sense that you can inherit some of the special record machinery and, for instance, override it yourself and stuff like that. But that's not quite there yet. So that's a C# 10 ambition. But other than that, perfect. Yeah, methods, operators, whatever you like. It's, fair game. It's really just a class with some extra bells and whistles.
Okay. I'll ask one question specific, and there's one general question that has kept coming up, and I'd like for us to just very quickly tackle it. So someone mentions the shorthand constructor of a record without the curly braces is cool. Is this feature available for classes as well?
Not yet, but this is a really good question, and this is yet another of my post C# 9 slides that we'll talk about before we get there. Okay. So we do want to allow ordinary classes to have primary constructors as well, like this. However, on an ordinary class, we don't want these to introduce public init only properties. Because that's, for a record, that's almost always what you want. You already have value semantics. But for a general class, we don't want to assume as much. So typically, the way it will look in a class is that, let's actually go back a little to where the properties were there. That was more than a little. Come on, there we are. So the way that we're probably going to do it is that we will allow you to put parameters here, but they don't become public properties. So in a class, so this is in a class, but they become available throughout the scope of the class for initialization or to use in methods and so on. So they're more like private fields. They stick around after the constructor and are stored inside of the object, and think of them as private fields. And so I could use one to initialize here, for instance. Or I could use them in, I could have the first name be a computed property that just returns the result of this field and so on. So we want to generalize this to classes and structs in general, but they don't generate the properties. It's the only difference.
Nice. Okay, perfect. And I have to ask this question. Not only was it asked once, but other people have brought it up quite a number of times. It's a general question. Do you see C# becoming a big name in the AI and machine learning area in the future, like Python currently is?
I hope so. I don't. So, with some modifications. Okay, Python is really sort of building on it. Python has a long tradition of being strong in science and statistics and math, and has really great libraries there and so on. So it's been natural to use Python also for the particular brand of statistics that is AI. AI is really a sort of like statistics. Applied statistics, if you will. And another thing that Python has going for it is that it is a language I'd say this in the best possible meaning. It's a language for amateurs. It's a language for people who don't necessarily do programming as a trade, right? It values simplicity over many other aspects, and so it's a very approachable language for someone who's primarily like a scientist or a data scientist or something, and only secondarily a programmer. So I think that Python's rise to prominence in this space is deserved, and it's not strange, and it's not something that we necessarily want to compete directly with. Now, that said, we do want C# to be used for AI, and we do want it to be very usable in these places. For starters, C# developers want AI in their apps, right? And we don't want to tell them, yeah, go hack some Python and call out to that, right? So absolutely, AI should be available. If you're consuming AI, if you're consuming predictors or something like that, you should be able to just stay within your C# world and get all of that. Whether it's like cognitive services on Azure, or whether you have your own AI running on your own machine or whatever, that should just be available. And that's where ML.NET comes in, and we've been working on that for a couple of years to give you a good consumer-oriented experience. Consumer as in the developer consumes AI. As for writing AI algorithms and so on, I think there's no reason why C# couldn't get good at this. Things like auto differentiation, for instance, that are one of the technologies that is used in AI, is like in neural nets, for instance, is one of the things that C# actually has a leg up on other languages, in that it has expression trees, and it has source generators now as of C#9, and has these technologies that let you generate the derivative of a function as code. So we could be good here, we just aren't yet. And we're also the kinds of environments that you often use Python in, like notebooks. We are also very strongly investing here, and we have some awesome. You should see some of Maria Nagaga's demos if you haven't. By the way, one of our total rock stars from Africa. Some of her demos of using C# Interactive in these environments, and so we don't want to shy away from having the same functionality as Python, and at the same time, we realize that being a general purpose language, C# may not appeal to certain cohorts, and that's fine. But we don't want that to mean that you just can't go there in C#. We want to offer that functionality.
Okay, perfect. Thank you. I think let's head back into the presentation. And to the guys in chat, thank you. Keep your questions coming, and we'll get to them. And thank you for really engaging. Bring them on. Keep the questions coming.
To be clear, this is exactly what I hope for. I take these questions and I go back and I'm like, okay, so maybe we should do this and that, because of the kinds of feedback I get here and because of the questions. This is great. Thank you. Now let's get into pattern matching. I don't know if you've all been following pattern matching over the last couple of releases. This is sort of the state of the art as of C#8 in terms of pattern matching. So I have a gigantic expression-bodied method here. This is really modern C#, right? I have an expression-bodied method, and the body of the method is a switch expression, which switches over the vehicle that comes in and has these various cases that each are guarded by a pattern. Okay, so there's a simple old-fashioned pattern here, car C, and then there are probability patterns here, and there's here's a positional pattern, and these are all like things that we put in C#8, and this is great. Okay, you can do many things with patterns, but not enough. So we're going to add more that you can do with patterns in C#9, because why stop a good thing? So let me show you. Apparently I have another meeting in 15 minutes. I guess I'm not going to go to that. Let's see a few new patterns that are added to in C#9. So first of all, this business about having to have a discard. I mean, the discard is nice, I don't have to put a name for the taxi that I realize that is here, but it would be even nicer if I didn't have to put the discard either. So we now have type patterns, which just let you say, if it's a taxi, go here. If I don't care, why do I have to say that I don't care about the specific taxi? So the taxi, the bus, the delivery truck, we can just do that. Now, another thing we have added is relational patterns. And so let's take the several of these sort of sections here for the different types. They use comparisons. Let's look at the delivery truck here. It uses numeric comparison operators here. We can actually now have patterns now that can compare things to constants. So which we call relational patterns, usually relational operators. So why don't we change the delivery truck cases here to one case that does a nested switch. So if we have a delivery truck, then we want to take its gross weight class and switch on that. Not which on it, but switch on it. And now you can see there's a remarkable lack of curly or sort of squigglies on this line here, because I can actually now, this is now a pattern in my nested switch expression. And we can take the other things here and turn them into patterns as well. And here we just, for now, let's just use a discard. And now we can end this nested switch and do a little indentation. And there you go. We have now used relational patterns to say, if that gross weight class was over 5,000, we get this result. If it was under 3,000, we get this result. And otherwise, we get this result. Okay? Relational patterns. Now, one thing that annoys me a little about this example is that they're sort of out of order. You know, I like my ranges to be in order of size or something like that. But I can't, because this one that's in between, that has two conditions on it, it has to be last, because I can't put two conditions in a pattern, or can I? And that's the third pattern feature that we're doing here, is that I can actually I can combine patterns into other patterns. So we can say if it's greater than or equal to 3,000, and it's also less than or equal to 5,000, then go in here. And by the way, let me put 4,000 here, just as a bug. Now you see, I get a warning on the switch saying that not all numbers are handled. So the compiler is smart enough to see that if you have just these ranges here, that you actually cover everything. Let's actually try to put 6,000 and see what happens. Oh, okay, it's fine with that. So as long as there's a way that you can get to the last pattern, it won't complain about that. So now I have the less than 3,000, I have the between 3,000 and 5,000, and I have the more than 5,000. And none of them is a fallback case anymore. They're all distinct. So I can take the 5,000 and move to the end, and now I can relax again. My code looks nice again. So type patterns, relational patterns, and pattern combinations, logical patterns we call them. We have and or and not, and we are not using the syntax that you have in expressions when you have do and or and not, which are the double ampersand and so on, because that would be way too syntactically ambiguous. So instead, what we do is we have these new contextual keywords that can occur in patterns only, that are actually the words and or and not. And for an example of not, one of the things people have been asking for is a way that I can have a pattern that is not null. And yes, there is. I could say not null here, and then throw this exception only when the object is not null. And then I could have a null case after. So not is one of these three that I can now apply to the null pattern. So there you go, some pattern stuff. And actually, let me show you something cool. Here is something that we showed in C# 8 as well, which is a not pattern-based little helper method that gets the time band. And you can see there's a lot of comparison in here. So let's click here and see. It suggests that it suggests some refactorings here. And one of the things I can do is convert to a switch expression. So we actually have refactorings for the new patterns. Look at this beauty here. This is actually, this diff here, that is the immutable data types in Roslyn at work, like we talked about before, just to go meta on you for a bit. But so it shows before and after, creating a speculative syntax tree of what the world will look like if I take the refactoring. Let's take the refactoring, and what you see now is that we are now switching on the hour, and we are using new relational patterns here, including the overnight band here at the end, which could be an OR pattern in this case. So there you go. That's patterns. Anybody has questions or comments on the new pattern stuff?
It looks like we lost Lawrence for just a minute, but we do have one question that is, why do we use and instead of ampersands?
Yeah, it's because of the risk of syntactic ambiguity. Let's say that we use ampersand here. Now, in this particular case, it wouldn't confuse the compiler with, it wouldn't be confused with anything else. But notice that this is an expression, and it just happens to not be a Boolean expression, so the ampersand doesn't apply here. But if this was a Boolean expression, and that, it would get very confused about, let's say it was true and something else. You'd get confusion about is this this Boolean expression, or is it this pattern and that pattern? So it's just as a matter of precedence and parsing and so on. It's just too hard, both for the compiler, but actually also for the human eye, and in some cases impossible, to distinguish whether this is about combining patterns or it's about combining values in the expressions in the patterns. And it's also sometimes the other way around. You have is expressions, and if you put an ampersand after an is expression, is it combining the Boolean that's a result of the is expression with something else, or is the double ampersand inside of the pattern in the is expression? So we're like, we can never do that. And if we want to have logical patterns, we do need to call them something else. Otherwise, it's way too much real ambiguity in the language. So that's why we went with that. I know that it takes a little getting used to, but we haven't even shipped this yet, and I'm already used to it. So I think it'll be okay.
Okay.
Great question.
I see. Oh, I'm back. Apologies for that. I'm looking at the chat, and guys love this. They really do. It's awesome. I love it too. And one of the questions that has come in is, can we do multiples for pattern matching?
Can you say that again? I lost the word. Can we do more what?
Multiple cases.
Multiple cases?
Yeah.
Well, I'm not sure about the question, but I mean, the switch expression has multiple cases. This is a switch expression doing each of these is a case. But if you want to combine cases, then that's what you can do with you can sort of do that with an and or with an or. An or is essentially the same as having the fall through in C#, where in C# switch statements, where you can have two different cases. That's probably what the question is. Yeah, if you have multiple case labels with the shared body, and yes, you can do that. The or is what gives you that. So if I want to have if I want to combine these two cases here, I could say less than 3,000, or something else greater than 10,000. And then I've essentially combined the two cases by having two different patterns, which would be separate switch labels in an old-fashioned switch statement, and combining them into one pattern. So it has the same effect. One thing that you get limited a little is if you have pattern variables like the C and R here, and you have or in between them, then we can't we can't know for sure. So we don't essentially let you use pattern variables here if they are sort of not if they come from more than one place that haven't necessarily all been visited. We can't know which of the patterns matched, and so if there was a variable in there, we couldn't know for sure that it was filled in with something. And so that's a limitation of the OR pattern. But other than that, yeah, this is the modern way of doing fall through essentially between labels.
Yeah, it's awesome, and I think the community loves it from all the. So it's a great feature, and yeah, guys are super excited to use.
Excellent. So we're essentially at where I have nothing more to show in code, but I can go back to slides, and there are a few more C# 9 features, and then we can talk about what's after C# 9. Is that okay?
Sounds good.
Let's get slides back up. And so just to mention a few other C# 9 features, there are way more. If you are interested in which ones are there, at this point, we don't have all the docs up yet, but some of them are up already. I mean, we haven't shipped yet, but they're already coming online. And you can also go and look at, and trawl through our GitHub repos and really get the lowdown on what's there. But here's one, target type new. Target typing in general is where you can write an expression that doesn't have a type, and then it gets its type from where it's being used. So that we call that target typing, and there's more and more of that in C#. If you look at a lambda expression, for instance, that's always been target typed only. You can only have a lambda expression if you're giving it a type by assigning it or passing it to something that has a type. Okay, but now you can leave out the class or struct name from a new expression, and if the new expression is being assigned or passed to something that already expects a type, then that type will just be, we'll try to insert the type there, and if it works, then you were lucky, and if not, then you get an error. So oftentimes when you're writing a bigger new expressions, maybe nested creation, that you're building up a tree of something, happens a lot when you're doing immutable programming, for instance. It gets annoying saying all these types that you know full well, and sometimes those types are generic. They take several type arguments. Things get long-winded. When you have, and you know the type that you need is right there waiting for this object. So why should you have to type it again? This is just an abbreviation thing, but really nice. We also have covariant returns. So what that means is that when you have a virtual method, you can now, when you override it, you can now give a more specific return type. Here I have a virtual method that returns person. Student is a particular kind of person. Maybe in an override, this method would always return students, this get member method. And so you can now specify that. And what that means is that if you call this method and you know you're calling it, that you're calling this override or something that overrides it, then you get that extra type information where you're calling it. So now you don't have to cast to student. You just the compiler just tells you, yeah, it's a student, it's okay. This is an example of a feature that is implemented not just by the C# compiler, but into the runtime. It used to be the case that we were really, since we did generics, we were really scared of making any changes to the runtime to implement new features. Because of the way that .NET deployed in the old days, being a Windows component and all that, we couldn't know for sure what .NET was where, And so it was really scary to have new language features depend on new features in the runtime. So we did all our fancy features with compiler tricks, async and everything. It's done purely with compiler tricks. But nowadays, with the .NET Core family and switching to the new .NET Core-based .NET 5 unified .NET, now we have, deployment is much more under control. It's something that you can do yourself. And you can have multiple .NETs on the same machine and so on. And so we don't have to worry so much about this anymore. And that means we can innovate in the runtime again in a way that we couldn't for a long time. And that is really great. We've done several things already that are implemented in the runtime. This is a small example of that, where the runtime now understands and accepts an override that has a more specific return type than the original and the previous overrides. So great little feature that we actually also use internally in the implementation of records for the with machinery. But other than that, if there are any more last questions on C# 9, we can take them. But other than that, I'm going to start talking about what's beyond for the last half hour or so.
There's one question on the new statement. So will the new work in method arguments? So for example, will the foo, my class C, and I think you can probably see this on StreamYard on the comment. It's right there. Could you use new to encapsulate the two variables? So for example, instead of writing person, could you pass the new into a method as an argument?
You can pass new into a method as an argument, and of course the problem now is from a language point of view is that method could be overloaded, and so what is the target type? Like one method could expect a person and the other one expects a student, and so it then creates a challenge for overload resolution, which is already an extremely complicated topic in C#. And so we had to decide what to do about that. And what we decided was to have a fairly defensive, so it does work, and but it has a fairly defensive approach where we don't just try it with all the methods and see if there's only one that works, we'll take it. We are a little more defensive so that you don't accidentally get the wrong method silently. So we have rules in place that make it kind of sane and that make it less brittle if your overloads change a bit or something like that. But it does work, and there's overload resolution that takes place in this case. Yeah. So great question. And that was the main design challenge with this feature, was figuring out how it works in the face of overload resolution. So spot on.
Oh, nice, perfect. I see one question on the record value. This is probably a step or two back. Can records be value type to avoid allocations for high performance scenarios?
Not yet, is the answer. They are classes in C# 9. But as I mentioned it briefly, and it'll be in the slides as well. We can come back to it. But essentially, record structs is something that we want to support. And so if you want to have allocation-free records, you can go and do so. Of course, structs come with downsides. You can't really build trees and that kind of data structure with structs. So, but yeah, if you want a record that's a struct, we're planning to support that in C# 10. In fact, one of the things we have to consider is, sure, if you have a record struct, it will have it already has value equality. All structs do by default, and so it will also support with expressions. But with expressions, really all they need is to be able to copy the old object and then modify it according to the object initializer you put in the with expression. And so we could, in fact, allow with expressions for all structs and not just record structs. And that's a design decision that we haven't made yet, whether to have width just be available in all structs, or whether it should be something you opt into by making it a record. But either way, we probably want to support the record struct syntax or struct record, one or the other, or both, and so that you can also have, your so that the if you put a primary constructor on them, that they can generate members and so on. So I think there's going to be an explicit record struct, not just all records or all structs are records or something like that. But it's not. We haven't settled on this yet. This is a topic that we'll try to settle in C# 10 and get something in there.
Okay, we still have a few more questions coming. So we have a question here. I love pattern matching. Can we support algebraic data types with the new syntax?
So algebraic data types is also, what's lacking from what is often called algebraic data types in C# now is, so the answer is halfway yes. Records and these abbreviations help with expressing types very succinctly. What's lacking is the ability to have what people sometimes call discriminated unions, where an object is either this, that, or the other. Like you sort of list, it has these three options, for instance, of the shape it can have, or what it can contain. There are kind of two flavors of discriminated unions out there. It's sort of, discriminated unions are sort of like the functional alternative to inheritance in a way, in that inheritance is how you get different shapes, different possible shapes into the same variable. And pattern matching is indeed how you can choose between it. So if you look at the, actually, if we go back to the example with the pattern matching that we had before, here, this is sort of like the vehicles that come in as object here, they are sort of like almost like a discriminated union. It's like this variable contains one of several types, and you can switch on which type it is. That's almost like pattern matching against a discriminated union. The question is, should we do something in C# that more closely models the declaration side of that is terse and is declared in one place? And maybe that where we make use of the fact that there's a limited set, like when you have inheritance, you can always have more derived classes, but maybe we make use of the fact that there's only 3, so that we can complain if you don't do all of them, and check that, do sort of completeness checking when you switch on them or when you do pattern matching on them. So that's on the radar for something to look at, and we will decide whether inheritance is good enough, or if we want a discriminated union-like feature to enhance inheritance. We wouldn't have it as an alternative, because that's about the language cohesion again. It has to, discriminated unions in C#, if we do them, they have to be closely related to inheritance. We don't want these two mechanisms that do almost the same, but that aren't the same. So it would be more like syntactic sugar or something on top of inheritance, but should it then be the one flavor or the other flavor of discriminated unions if we do them? That kind of thing. So there are many open design questions, but it's on our radar to look at. And if we don't get to it in C# 10, we'll get to it in C# 11. And we have lots of these like long-term things on the agenda that just keep percolating around and accumulating evidence and ideas until we feel like, okay, now we got it. Now we understand the key scenarios. And now we know what's best for C# in this regard, and then we go. So okay. This is one that might take longer, but we'll keep looking at these scenarios that motivate algebraic data types.
You actually answered the next question, because it was about discriminated unions. So yeah, perfect. I think we can definitely continue, and we talk about what's beyond C# 9.0.
Great. So beyond, I think there are several themes, many of which I mentioned, that I'm not going to get into more. There'll be more of, we talked about the simplification already, how there are more things that we can simplify, and the many themes. I'm just going to touch on a few here. I might not even get to all of them today, but as I mentioned several times, records and initialization and all that stuff was a big theme in C# 9, but we only got part of the way. We carved out like a close set that was a great first start, and now we're going to keep building on that for probably a couple of releases. So we have several ideas here that we are going to double down on, probably for C# 10, many of them. Things that might be further out are things like statics and interfaces, and things that we call roles and extensions, which I might get to at the end. So we'll just touch on a few here, but let's start with the things that build on what we just saw in C# 9. So I mentioned already the data properties, which would essentially take these init-only properties and abbreviate them down to this. And again, just get code more terse and focus on what's important. And you can do this either in records or in classes. It's the same thing, right? So now they can be on one line. Yay, you have one-line types now. That certainly was, we've come pretty far from C# 1 when you can have one-line types. So another thing we're talking about is factories, which is the idea of methods. We don't know how to annotate them. I've just put an attribute here to say that a method is a factory, but maybe it should have its own keyword. And when a method is a factory, that introduces a new contract on the method, which is that it has to create a new object. And so a factory is fairly limited in what it can have as its body. It has to return a new object or something that was itself created with a factory. What you get for that, though, is that when you have a factory, because it guarantees to create a new object, you can actually use object initializers on the result, right? So if I have a copy factory here that returns the same person as the one I already have here, or one that is equal to it, then I can call that copy method, and then I can apply an object initializer to that. And now maybe you go like, haven't I seen this before? That's actually how with expressions work under the hood. There's a special compiler generated factory already today that we know what it's called, and it has a special compiler generated name, and it behaves like a factory in that sense. And that's what really gets called. It's really like a copy method, and it gets called when you use a with expression under the hood. That's what that translates into. So that really translates into a virtual copy method that each class in a hierarchy can say, and the compiler generates in the case of records, what does it mean when I'm copied? What exactly does it mean when I'm copied? What gets copied over and how? And that's what I mean by saying that, or part of what I mean by saying that in C# 10, probably you could write your own record, is that if we make factories a feature, then with expressions are just a special case. With the with pattern is just a special case of using this feature. Compiler generated in that case, but you could write it yourself. Now, the next thing is that one of the downsides, so we're trying to address some of the downsides of object initializers compared to constructors. One of the problems with object initializers is that they happen after the constructor, right? I create a new student, then I assign to the properties of the student. So if you have any validation logic that runs in the constructor, well, it validates the object before the new values came in, which is pretty useless. One of the things that we're talking about is that a class should be able to have a final initializer, which is, this is tentative syntax again, but which is code that runs after any object initialization has happened. So it's guaranteed to be the last thing, or there might be a chain of final initializers of the inheritance hierarchy, but that should be the last thing that happens when the object is fully initialized. So it initializes the final state of a newly created object or it is able to validate that. In this case, the name can't be longer than a certain thing. That's a validation that goes across all the properties, and it's no use validating this until the strings have actually come in. So that's another feature, final initializers, that we're thinking probably fits in C# 10 if we can get it right. Now might be a good time to take a few questions. I see there are some coming in.
Yes. Hello. Oh, perfect. So I think people love the new features, but they also, I believe, are suggesting a few of their own. So a lot of these are most likely, a lot of these are going to be questions around some of the features people might like to see. So are there any plans to add an interface for numbers? So something like iNumber?
Yes, and that's actually one of my next slides. So so I promise you I will get to that. We can actually, well, you know what? Let's streak ahead and let's talk about that. Why not? Don't have to do things in order. We can come back to some of these. This is it. So let me spend 5 minutes on that. I was hoping we would get to this, so you're making me jump ahead to it. The problem with numbers is you'd like to abstract over different kinds of numbers, and you want to write generic algorithms that can work for any number that has the right numeric operations, for instance. And you run into this very often. And C# and .NET, they suck at this. It's really bad because you can't abstract over operators. You can't abstract over anything static. You can't say this class needs to have this static method and this operator and so on. But what if you could, right? So one of the things we've been exploring, and this is actually, there was a prototype of this nearly a decade ago that we left because we couldn't change the runtime back then, but we're looking at again now, is the idea that interfaces can specify static members that are then required by their implementers to be implemented. So here's an interface that represents the mathematical concept of a monoid, which is simply something that has a neutral element. It's a type that has a neutral element and some operator over the over the elements. That we call the addition operator. So obviously, for instance, integers are a form of monoid. They have their own zero element, which is 0, and we could express that as giving them a static int that is the 0 element, and it already has a plus operator as well. So we could say, hey, int implement this monoid interface, and now it satisfies the requirements of that interface. So far, so good. Now, how can you use that? Well, the idea is you would use it in generics. So if I want to write a numeric algorithm that works over monoids, let's say I take a, so I can do that by having a generic method here that is where the type parameter is constrained by the interface here. And that means any class or struct that gets passed as the type argument has to satisfy that it implements this interface. Now, if I take an array of those guys, whatever they are, then I am now allowed to call the static method 0 on the type itself and to take each of the elements in the array and plus them together, because we have the 0 static method and the plus operator specified on the interface that I satisfy as a constraint. So this feels like, so static members and interfaces feel like they're the gateway to numeric abstraction. And then on top of having that language feature itself, we would then have a library of interfaces that represent common numeric concepts, rings, fields, and groups, whatnot. We would have a set of interfaces, and we would implement them with our own numeric types, as well as allowing anyone else to implement them and plug into any generic algorithms that abstract over numerics in this way. So great question, and that is actually something that's on our radar. Now, this requires fairly significant runtime changes to allow it's not actually difficult. It's just a lot of stuff that needs to happen, a lot of dotting of I's and crossing of T's. So this feels to me like something that I don't expect that we would get to in C# 10. We'll try, but it might be a little later. But I do want to push on this. I think this is how C# and .NET can finally become great for numerics. The performance is nearly there now. We have lots of stuff that make for great performance in numerics, but the syntax and the abstraction still leaves something to be considered. So hopefully this can be a big improvement on that. Next question, if there is one.
Okay, so I see we'll most likely close off in a few. As you can see, I'm joining you from on my mobile phone. Hooray for technology. Okay, so one of the questions we have around factories is, does a factory only need to create a copy of the list, or does it also, or it also has to create new items in a new list?
I think, in this case here, the factory would probably, it would initialize, it wouldn't just call the constructor and person, it would copy over all the elements of the person. But a factory can do anything it wants, really, as long as it does it on a new object. So it can create it using a constructor and object initializer and so on. But it, yeah, I don't know if that answers the question entirely. You don't have to use it for just copying existing objects. You can use factories in all kinds of scenarios. Static factories is a common thing you have today, where people have a create method on that's static, that sits on the type. Tuple.create in the framework, for instance. And if we make that a factory method, then you could use object initializers on top of it. Stuff like that.
Okay. I think looking at chat, a lot of people love iMonoid, so I think everybody's eagerly waiting for that to be released. And so I see we also have to start closing off. We're nearly at the top of the hour. And I think I'll ask just some of the questions that I've seen people ask. I think one, I'll ask a few feature questions and then close off with a few general questions. So one is, can you chain factory calls and still use init?
Yeah.
Okay, perfect. And are there any plans for functions outside classes? So something like what C++ does?
Great question. It's something we're talking about. It's like almost any question you ask, I say that, and so it may sound like we just talk about everything. That's not entirely false. If we go back to the, it's hopelessly maimed now, but if we go back to the program we were mucking around with before, you see that there's a top level function here, but don't get too excited, because this is really like a local function. It's local to the main method that's just on top here. So this display person function here I can't call it, for instance, from the class down here. It can only be called from within the program. It's still just a local function. But we did take great care that it's still visible inside a person, and you just get an error if you use it. And the reason we did that was so as to protect our ability in the future to make this mean something more, to allow top-level functions to actually be a top-level declaration that can be used, that's part of the library, so to speak. So by default, like a top-level class, it would be internal and would only be usable from the main program as now, but also from class declarations around this particular assembly, this project. But you could also put public on it, which you can't now, but in the future you'll be able to put public. Now it's part of your public surface area as a top-level function that when people have a using to your library, they can get that, or they can dot in through the namespace directly to the function. So that is a potential new feature that we could do. There's a lot to iron out where we could probably do it. One thing we're actually a little unsure about now is how big the demand is and how much people want this, because it's a big new front to open to say, oh, now we have top-level functions in C#. Whoa, that's a new thing. Do we really want to get married to this feature? So we still kind of lack a little on the desirability here before we decide to double down on it. But it's definitely being considered. Yeah. I can't hear you.
Speaking of, yeah, it's a different interface. It's taking some time to get used to. But speaking of some of the new features, there's an interesting question here. If any of these changes result in updates to the runtime, will that improve things for F#?
The answer is likely yes. It's certainly if it affects the surface area between assemblies. You can have F# calling C# across assemblies and the other way around. And so if there's new things that can be exposed in an assembly, then F# needs to decide, same for VB, it needs to decide what to do with that. And they can either sort of, and so they do consider this, and we do talk, this is something we talk about with the F# team. Sometimes they fully embrace this as a new feature in C# or in F# as well. Sometimes they have sort of like a defensive thing where they make sure they can deal with it, but they don't surface it in F#. So there's these things, that's one of the sort of downsides or challenges of evolving the runtime itself, is how does it affect the other languages on top of that runtime? And that is something like VB in general, the language strategy will tell you, in general, we don't evolve VB much anymore. So we pretty much just tend to harden it against new things it might encounter in an assembly. But for F#, it's very much still an evolving language, and these things are being discussed for each of these is being discussed for F#. What's the best way to surface it in F# and to interface with it?
Okay, so okay, I think I'll take one last question. Actually, these are the final two, but this is the last one on the platform. Will C# offer enough syntactic sugar for embedded DSLs?
I think, so embedded domain-specific languages, I think that's always going to be a bit clunky in C#. C# wasn't built for that. I think that you're much better, for that kind of thing, you're much better off going to F# generally, where you can get your abstractions down to, it really feels like, so you can build a library that when you use it, it feels like you're using a language within the language. I don't have that as an ambition. I think that is, so far, that's a bit too far for C# to reach. And so I would say that for now, go use F#. It's a great language, and it has different strengths than C#, and this is one of them.
Okay. And so I think one of the greatest things, and I think this has become pretty apparent from the questions, is people have lots of ideas, they have lots of questions, and I think the one thing that everyone is asking is, how can they contribute? How can they share these ideas? Where do they go to share these ideas with you and the team as you build the future of C#?
Right. So the place where that mostly happens is the GitHub site here. Start out with a discussion. There are plenty of people on here who will give you, who will engage in a discussion with you around new ideas. The discussions are fairly new as a GitHub feature, so many of these things that have already happened still sit around in GitHub issues, not discussions. But go here, that's the best start. If you want to ask a question or something, you can go to Twitter. I forgot to put my things on Twitter, like my Twitter handle, and I'll just do it in code here. I'm Mads Torgersen on Twitter, or if you want, shoot me an email at Microsoft. mads.torgersen@microsoft.com. Feel free to contact me through either of these channels. The Twitter gives better opportunity for discussion. This is for me personally. Same goes if you're running a user group and you want to chat with me or one of my teammates, just send me an email or ping me on Twitter, and we'll get it set up.
Okay, perfect. And as we close, are there any closing remarks you want to make to the amazing community? Anything you want to say? Over to you.
That would be a big thank you. The community engagement is really what, as you can see, that's what drives our innovation, and that's what makes us passionate about doing the next things. And at something like this today, this has been 2 hours of pure bliss for me, except for when I lost internet. That was a little stressful. And so this is just great. I want to say big thank you, and I hope we can engage a lot in the future as well.
Okay, thank you. Thank you very much, Mads. Thank you for making the time. But most of all, guys, it's a thank you to you, the community. You've spent that time with us. You've asked the questions, and we're here to answer. And so we hope you've had fun. We hope you've enjoyed it. We hope you've learned a lot. I'm super excited, and I want to actually go and try out a lot of these things. And I hope you will too. So go out there, write some code, and as always, stay awesome. But before we head out, I'd like to give a big thank you to the people behind the scenes who made this happen, to Melanie and the amazing DevRel team at Microsoft, and to all the amazing people who put this together. Thank you, guys. But most of all, thanks to you, our audience. We really do appreciate you. And with that, have a lovely day. And if you're like me, have a lovely evening. And if you're somewhere else enjoying the morning, have a great day ahead. Thank you, Mads, and thank you, guys. We'll end here.